it, I'm Xander Evans. I'm the research director at the Forest Stewards Guild and also part of the Southwest Fire Science Institute. And so what I want to do here is just walk through real quickly. It's going to be a speed walk through the 2016 fire season. And this is based on a report that will be coming out hopefully this week, maybe next week, in partnership with ERI. And it just kind of summarizes the fires and doing and it gives us a way of sort of thinking about how the 2016 season compares to other seasons. And so one way to do this is to just look at how many acres have burned out there. And you can divide that out in terms of the record keeping between prescribed and wildfire. And so we can see we've, since 2011, we've had a pretty low baseline. And those percentages there are the amount of prescribed fire. So 19% of the 2016 year was prescribed fire. So sort of in line with past years, maybe a little bit more than 2012, where we had a similar amount of total acres burned. And instead of trying to review every single fire that burned last year, what I've done is really focused on the 12 biggest, and these are all 8,000 acres or more fires, and they're the ones that are labeled on this map. And you can see all the small X's dotted around the rest of the state are all the rest of the fires. I think these are all the fires over 100 acres, but there are a lot of them. And so it is a little bit difficult to sort of summarize the season, and we thought that focusing on the biggest ones probably is the most effective. So I should have said this before, but feel free to type in questions in the chat window, and we'll sort of try to pick them up at the end. While I'm talking, I may not be able to respond particularly well, but feel free to put them in there, and we'll address them as we go. One of the ways we can think about the fire season is through the energy release component. And these are graphs that Predictive Services produces. So Chuck Maxwell sent these along to me. And I find them a useful way of kind of gathering my thoughts about at least one measure of the weather conditions. So probably folks on this call know more about energy release components than I do. So I won't go into a lot of the details about how it's calculated, but my sort of basic understanding is it integrates both the moisture of the fuel as well as the ambient weather and temperature. So I'm going to go through chronologically, and the first large fire of the season was the McKenna fire. And so you can see it started in a time when the energy release component was lower down here than the average, which is this gray line. So we had sort of periods of wetness that I think led to the fact that this ERC was fairly low by May 6th when the McKenna fire ignited. And the McKenna fire was a natural ignition. It burned about 10,000 acres, mainly in ponderosa pine. And what we have on the screen now is the canopy mortality map, and most of it is green, and so that indicates that very little mortality happened. And in fact, about 97% of the McKenna fire was in this little impact category, less than 25% canopy mortality. It costs about $20 an acre to manage the McKenna fire, and one of the things that's a little bit hard to see in this map is the Miller fire was over here in 2011. So all this area on the other side of the red dotted line was the Miller fire. And then the Whitewater Baldy complex burned this whole side of the map that I'm outlining in purple in 2012. And then the McKenna fire here in the middle reburned both of those fires in 2015. And in fact, this small area in the middle burned for the third time in the last 10 years because it burned in the Horse Fire in 2010, and then in either the Whitewater Baldy or in the Miller Fire, and then finally in the McKenna. So I think sort of neat to see this recurring burning with low severity in ponderosa pine, where it's a fuel type that's adapted to that kind of burning. The next fire in the season was the Coyote Fire that started May 7th, and that was about nearly 14,000 acres down in Texas. And that was in pinon juniper woodlands with some grasslands. We don't have a severity of either a soil burn severity or canopy burn severity map for this fire. But we do know that it burned through some areas that had previously burned in the cutoff fire in 2010, and it cost about $360 an acre to manage. Moving through the summer, the next fire was May 20th, and that was a lightning-caused fire in Arizona called the Juniper Fire. And we can see that at that point the ERC was still lower than the average. So again, the average was up here, and the Juniper Fire started at a time when the ERCs were fairly low, but they were increasing as time went on while the fire burned. So the Juniper Fire, here's a shot from as it burned. We can see in this picture it's sort of backing down the slope and seems to be burning with low intensity and probably low severity. But that wasn't true for the whole fire. We can see from the canopy mortality map that there were large areas of high severity, areas on the east side over here where big patches were with total mortality, greater than 90%. Even in an area where the fire burned again for the Coon Creek Fire, I don't know if you can read that, but it says Coon Creek burned in 2000. The Juniper Fire reburned it in 2016, and there were fairly large patches in that matrix of canopy mortality as well. So overall, let's see if I have that number in front of me, about a third, about 10,000 acres where the canopy had greater than 90% mortality. And there's a sort of mix of forest types in this, or vegetation types, I should say, in this fire. A lot of it was conifer oak or pinon juniper. That made sort of the majority of it. But there were some grasslands as well. The Juniper Fire cost about $400 an acre, $380 an acre to manage. And it was managed for, at least during portions or on some sections of it, it was managed to benefit the resource and bring fire back as a natural part of the system. The next fire started just the day after the Juniper Fire on May 21st, and that was a lightning-ignited fire, the North Fire in New Mexico. And the North Fire, in this photo, ended up burning about 42,000 acres in a mix of ponderosa pine and pinon juniper. But in a difference with the Juniper Fire, it only about 6% of, oh, I have that wrong here. Sorry, I don't have my percentage in front of me. There's a typo here in what I'm reading. But as you can see from the ravage map, smaller patches were in that high severity category. A lot of it was in a, left a lot of the canopy standing, so a low severity fire. And again, it burned up along at least one boundary with the Red Canyon Fire from 2015. So I don't believe, some of this I have to do from memory, so I'll refer you to the report for all the details. But I don't believe it burned portions of the Red Canyon Fire again, but they shared a boundary. Oh, here's my number. 76% of the ravage map had less than 25% canopy mortality. So 3/4 of what we have mapped for the North Fire was in the sort of low severity category. And again, that was managed at least in large parts, to benefit the land and the resource, rather than with full suppression tactics. So moving on quickly, I warned you this would be a quick review. The next large fire ignited on May 29th, again by lightning. So we're seeing so far all the fires we've talked about were lightning ignited. May 29th, the Jack Fire started and ended up burning about 34,000 acres. And it was mainly in Ponderosa pine. Now, in our reporting, we look at two kinds of maps that are commonly produced. One is the soil burn severity, like we're seeing right now on the screen. But the previous ones I've been talking about are these ravage maps, these canopy mortality maps. And there's some difference between the canopy and the soil burn severity maps here. You can see there's some patches of high severity for the soil burn severity, but they're fewer when we look at the canopy mortality. So there's some areas that seem to have, and that may be some areas of where grass is a bigger component, although most of the Jack Fire was Ponderosa pine. 90% of the Jack Fire had less than 25% canopy mortality. So even though there were some areas of soil burn severity, high soil burn severity, most of the canopy survived. And you can see that although it didn't burn again, it's in a matrix of past fires from the last decade, which I think probably helped the fire managers. It cost about $44 an acre to manage the Jack Fire, and in large part it was managed to benefit the resource. The next fire, the Mule Ridge in southern Arizona, started on May 31st. The cause was unknown, and it burned about 8,500 acres. You can see it backs up. There's a lot of fires that have gone on in this region in the last 10 years. The Murphy Complex is probably the most notable. But the other thing you can see from this canopy mortality map is there are areas of complete canopy mortality. Now, it's a little weird to talk about that metric when we're talking about a vegetation type that is scrub or grassland, as about half of the Mule Ridge Fire was. So how we interpret that is probably a little bit different than if it was in a forested ecosystem. But we also know that about 43% of the soil burn severity map was in the high severity category. So it had some severe impacts on the resource. It cost about $160 an acre to manage. And then as we move into June, we move into back into New Mexico with the Doghead Fire, and this is the first sort of documented human-caused fire of the season. This was about an 18,000-acre fire, and I guess while we're looking at this map, I should sort of note that we're seeing our ERCs climb back up towards the average, towards the sort of high point of the summer, this 90% line. So this is obviously, you folks on this call know this stuff, but this is during a time when more energy is able to be released as the fire burns. It's going to be burning more intensely, and that certainly fits what we see with the Doghead Fire. The Doghead Fire burned with high severity in a lot of areas. See if I have that number. So 2/3, 66% of the area experienced greater than 90% canopy mortality. And it actually, looking at this map, it looks like even more, but I guess that's just a trick of the eye. It was expensive to manage, a lot of homes to try to protect, very difficult to fight, and so it cost about $600 per acre to manage the Doghead Fire. I think, so yeah. So a related report that I would recommend if you haven't seen it is a look at some of the fuel treatment effectiveness, and this was specifically on private lands, but this is available on the Edgewater, I believe, Soil and Water Conservation District's webpage. You can also email me. I'll try to put it up later. But it has some good information about sort of the details of where the doghead fire burned. And actually, BIA has a similar report for Isleta. And let's see, what else about the doghead? Mainly burned in ponderosa pine and pinon juniper. And yeah, it was caused a lot of evacuations and pretty big impact on people. The cedar fire, again, like the doghead, started at kind of as we're picking up in ERCs. Thank you, Tim, for Edgewood, yes. Edgewood Soil and Water Conservation District. Cedar fire burned right at when our ERCs were sort of in the 90th percentile, and it had an unknown ignition, so possibly human cause. Really, the managers responded with a full suppression approach, partly because of the unknown cause, but also because of values at risk. It ended up burning about 46,000 acres through a mix of pinon juniper, conifer oak woodlands, ponderosa pine, sort of fairly evenly split between those types. And the majority of the fire caused greater than 75% canopy mortality. So all those red areas you can see on this map were canopy mortality. And I guess it's worth noting this map comes directly from the BIA report on fuel treatment effectiveness. Although these maps, the canopy mortality maps exist, I wasn't able to get access to them. There's definitely some data sort of availability issues that differ as we cross over onto tribal land. That's perfectly expected, but it does mean that's why the maps look a little different. And so the cedar fire, if I didn't mention it, burned on the White Mountain Apache Nation. One thing that came across from reading this fuel treatment effectiveness report that I thought was fascinating to me was that the playground fire from last year that burned over here in the red hatching right along the border, the sort of northeast border of the cedar fire, was really instrumental in allowing them to gain the suppression control that they wanted on the cedar fire. And so one of the managers noted that the playground fire really helped us. Quote, "We picked up every spot fire that went in there. That helped more than anything." So it's a good example of where the proximity of these fires year to year makes a difference in how they get managed. It costs about $300 an acre to manage the cedar fire. The next fire on our list is the Brown Fire in Arizona, and that was human-caused. It burned about 12,000 acres in mainly conifer oak woodlands and grass, and I'll turn on the next layer. 90% of it, 91% of it burned right in the footprint of the 2009 Elkhorn fire. So again, we're seeing this sort of reburning, and it costs about $115 an acre to manage. We don't have, or I don't have, severity mapping for this fire. Next fire, we're sort of moving late in the season now. By June 29th, the Fuller Fire was ignited by lightning on the Grand Canyon National Park. And this fire burned for a long time. Burned for, I think, 90 days. And so I think that's sort of interesting in and of itself that it was creeping around. It didn't end up burning all that much, 15,000 acres over that 90-day period. But my guess is that long burning time added to the management cost. It ended up costing about $830 an acre to manage. It mainly burned in mixed conifer, ponderosa pine, pinon juniper, and did interact with some past fire like the Woolsey fire from 2011. So it kind of kept with that trend from 2016. The Clavel fire started July 9th and burned about 10,000 acres of grassland in New Mexico. Costs about $5 an acre to manage. It really sort of burned quick through that kind of flashy fuel. We don't have a lot of information on it. It was a brief fire. So we'll jump to the rim fire in Arizona that started on July 21st. It's about a 9,000 acre fire that burned through pinyon, juniper, ponderosa pine, and riparian forest. This little shape here in the middle is not the full boundary of the rim fire. When I was making these maps, that full boundary was not available. But what we can see is that it burned in a matrix with the sawmill fire and the Elwood. So this is on the San Carlos Apache Nation, and they worked for a lot of years to put together sort of a natural mosaic of fires, and the rim fire added to that. So the last fire that I'm going to mention, and then I have a couple of summary slides, and then we'll jump to the 2017 overlook. But I did want to mention the Fresno fire, not because it was big. It was actually only, it was less than 300 acres. But it won an award in the Southwest Fire Science Consortium because of the way they engaged science and the sort of vision for the future condition of the landscape into their management. And hearing about the fire, we really felt that the managers deserve some recognition for their efforts. I know there's a lot of good management that goes on out there, but just to pick one particularly good example, we focused on the Fresno fire. And this also, if as you're working on fires this season and you see particularly good use of scientific information or a management approach, please do let us know, because we'd like to be able to recognize these fires, the teams that manage them. So I have a couple of quick slides on sort of an overview of what happened, what kind for 2015. And most of the acreage burned, over 80,000 acres, and this is the 12 big fires, was in ponderosa pine. This is in contrast to some past years like 2013 when we saw much more mixed conifer burn. But we're seeing now more ponderosa pine and pinyon juniper. So maybe more related to some of the weather, and I'll leave that to wiser heads like Rich in a minute. When we look at soil burn severity, we only had 4 fires for which we had good soil burn severity mapping available to me. And so we see that actually, at least in these 4, there was significant acreage of high severity fire, a lot of that due to the juniper fire. Another way to look at the severity is the canopy mortality. And we had more fires that we could put into the sort of summary here. And you can see actually there are a lot of acres, sort of, let's see, what does that add up to? Probably over 90,000 acres where we have less than 25% canopy mortality. There still are 30,000 acres of this high canopy mortality, mainly due to the doghead and the juniper, but we have a lot of acres out there where we have a very low canopy severity. So that's an interesting thing to note, and I talk a little bit more about that in the report. Another way to think about where these fires burned is the vegetation condition class. This is land fire mapping that looks at how departed from historic conditions the landscape is. And most of these fires were burning in low to moderate conditions. And so that suggests, at least to me, that there's some link between some of that lower severity we're seeing and the fact that their fires are burning in areas that are less out of whack. So one quick way to think about that is density, right? And of course, the other thing we notice is that a lot of the areas that burned, which were most different from historic conditions, burned in the doghead fire, which we know burned severely. So there's a link there as well. This slide I have back up to remind me to mention that all of the fires that burned or all the 12 big fires that burned in 2016 interacted with other past fires. So that's more and more, at least in my view, over the last few years, becoming a more important context issue, that they're either reburning or burning up to past fires. And this is just a reminder for me to make a quick note about the language we use. So I use the phrase fires managed with strategies other than full suppression, and I use that language because it comes out of predictive services in the incident management situation reports. Using that framework, that there are different ways to manage different parts of fires, we can look at the strategies that were employed. And so orange on this graph is strategies other than full suppression, and then purple is full suppression. And what we can see is in years like 2015 and more recently in 2016, we have a lot of acreage in fires managed with other strategies. And in 2016, even parts of fire, so the percentage of a fire was sort of broken out by the strategy used. And it's a little dicey to go out on a limb like this, but when you try to look at the costs, we see that where fire managers were able to manage with other strategies, they were able to not only have firefighters sort of removed from harm's way, but it also costs less. So it's about $200 an acre for those fires managed with other strategies, or those areas of fires managed with other strategies, and areas where firefighters had to use full suppression strategies, it was $287 an acre. So some differences there. So at risk of moving too fast, I'm going to leave it there, and we're going to jump over from 2016, and we're going to change gears to 2017. And I'm very pleased that we have Rich Naden on board to talk about the 2017 fire season outlook. And Rich has been a fire weather meteorologist in the Southwest since about 2003. He works in predictive services, but he also has about 6 other jobs, one of which is smoke coordinator, so working with folks doing prescribed burns on smoke, as well as managing the RAWS stations. So I'm really pleased, Rich, that you were able to take time out of all those tasks to talk to us today. And I always enjoy these predictive services outlooks for the season because it kind of gives me some sense of where we're headed. So with that, I'll turn it over to you, Rich, and then at the end we'll wrap up with a few questions. So if you have questions, feel free to type them in the chat window as Rich is talking.
Thanks, Xander. As Xander just mentioned, my name is Rich Naden. I'm one of 2 fire weather meteorologists located at SWFSC, or the Southwest Coordination Center in Albuquerque. Welcome to 2017. So we're going to be talking about what the considerations are for this fire season and what the outlook is at this time. This is something that we began doing about a decade back or so. Really grappled with it initially in regards to how to portray it, what factors to look at, but I'll be showing that here in a moment. We really begin this in December, January, and then it kind of is more of in a brief mode at that point. And then we kind of update it on a monthly basis all the way into our last update, which is in early to mid-May annually. So the next update will be in a few weeks. So this is a slide that we put together recently that just indicates what's going on, and kind of what Xander was talking about with some of the incidents of fire throughout the Southwest. And if you notice here, especially on the, let's see here, as we go into these areas of the last maybe 4, 5, 6 years, we're starting to see how, like he said, different type of management strategies are starting to be employed here compared to suppression was more the predominant phase as we look back at the 90s and especially the early 2000s or so. So we're starting to see this become more reasonable for our people to implement out in the field. A lot of it's due to the weather or the weather setup as we move into each fire season. But in the Southwest area, our fire season here is set up with a 50-50 split. We have human and lightning caused fires, which is different than a lot of other parts of the country. For example, the Pacific Northwest is primarily lightning oriented, where the southeastern United States is more human related starts. Second bullet there, human-caused fires more prevalent generally in the springtime. Right now we are definitely in a predominantly human environment for starts, coincident with these breezy and windy conditions, which we'll be seeing more tomorrow and perhaps across western Arizona Friday and Saturday. Lightning-caused fires much more prevalent as we get through May, especially by June, when we get more moisture moving into the region. So what are these 5 factors that we review annually and are constantly updating? Well, as you might imagine, drought's in there, so that's definitely one of them. So drought's one of the factors we're looking at all the time. What's the big picture regionally for our drought system or for our drought complex? The fine fuels, what are the fine fuels like around the region? This one, I think, is going to be evolving in a way where we're going to have much more regular information in the next few years. And be able to portray it much more schematically in regards to where these fine fuels are worse and be much more detailed. So I'm excited about that. Seasonal temperature and precipitation, point number 3. What was it like over the late fall, the winter time, into the early spring months? What was the precipitation situation like? Was it cooler than normal? Those types of things. Number 4, what's the weather pattern like in the springtime? Which is really the most pivotal one. I think number 4 really has a huge impact on what the fire season turns out to be. So the period from March into April into May is critical. We can have the most vigorous setup in regards to drought in the fall and the winter, but if we get a wet spring pattern, it really changes the situation for the fire season. And number 5, the monsoon, the season-ending event. So let's look a little more closely at factor number 1, drought. Right now, for the 6-month change, we got a 6-month change map here in the upper portion of the slide on the left. The U.S. Drought Monitor. Again, these are a bit dated. These are a few weeks old, but that's how we do it. And here in the bottom left is the drought outlook. So just glancing at these briefly here, for the 6-month change, we had pretty much drier than normal conditions across the eastern half or so of New Mexico into adjacent West Texas, and much wetter here in Arizona, especially in California, out of our region here, where they had pretty much a lot of the drought, which was so horrible for them for the last few years, pretty much taken apart over the winter time. The drought monitor at this time, or at least a few weeks ago, showing some moderate drought across far south, southwestern, southern Arizona, some speckles of abnormally dry across eastern Arizona, southeastern Arizona, and some abnormally dry conditions across much of the eastern half of New Mexico, with perhaps some more worse drought, if you will, across far, far northeastern New Mexico into adjacent western Kansas, western Oklahoma, and eastern Colorado. But really, when you look at the big picture, it's not as bad as it's been in the last few years. You know, in the last decade or so, looking at drought for the Southwest going into the fire season, it's really backed off. It's not as significant as it might have been in other seasons going into the fire season. Right now, it's things have changed a lot, as they typically do in the springtime. In the last 6 weeks, we were super dry in the eastern plains a while back. And we've had some periods of moisture the last 4 to 5 weeks with some coolness. So a lot of these areas have backed off a ton in the last 3 to 6 weeks, which has really helped those areas immensely. Jumping to factor number 2 briefly here, fine fuels. At this time, one of the ways we choose to evaluate it is by looking at past season or the previous year's precipitation patterns. So this is specifically looking at last summer into early fall of 2016 to try to get an idea about the carryover of the warm season fuels driven by precipitation during those time frames. So as we look at this last June, this was the beginning of the monsoon time frame, if you will, generally wetter west of the divide, or at least normal, near normal, with some areas of wetness across southeastern Arizona. A bit drier across much of New Mexico with some areas of more moist conditions as well. As we got into July, the monsoon slowed down or stopped, or whatever, never got going on time, if you will. I remember being in Albuquerque mid-July, and people were asking, what's going on? But we knew it was coming, and certainly by August, it really reinvigorated itself, and much of the region got moist and wet, which it normally does during the summertime. And in September, it was more focused across maybe the southeastern half or so of the geographic area. So what we do with this, we kind of correlate this. We talk to a lot of people. We get pictures from people in the field to see what the fine fuels and the carryover season fuels are going into this fire season. So when you kind of compilate all this stuff together, if you will, good carryover fine fuels, we have additional spring growth ongoing right now, really a significant amount of fine fuels area-wide right now to potentially carry fire. We definitely saw this in the winter months here and in the early spring across the eastern plains of New Mexico and West Texas. We had some significant fires near Amarillo and across portions of the eastern plains back in February, more so March. Now those have backed off as we've moistened up in those areas recently, but those were all carried by fine fuels. Now we're starting to see even portions of the southern sections of the geographic area also have these large amounts of fine fuels available right now. So we're characterizing the fine fuel loading and the continuity right now as normal to above normal, nearly area-wide. And here's just a few pictures of that large fire in northwest Texas back in early March, and the fuel loading around Carlsbad also. This was about 6 weeks back. So a lot of fine fuels there. Factor number 3, looking at the seasonal temperature and precipitation pattern. This is looking at the time frame from December all the way through February. So 3 months together. Temperature is the upper left. Precipitation is the lower left. Pardon me. A lot of above average conditions here for temperature, especially along the east of the Continental Divide in this general vicinity here. I have the southwest area encircled with that black circle. You can see a tint of cooler conditions for the wintertime across the western third of Arizona, maybe across far northern mountains of New Mexico and adjacent Colorado. A lot of wetness, though. A lot of this bluish and purplish is symbolic of above normal precipitation for that 3-month time frame. And looking at the snowpack here in the bottom right graphic, this is of early March here. A lot of blue and green, indicative of above normal snow. And these are just taken at mountain locations, as snow-tell sites. So that's why you're seeing big gaps across the areas where we don't have a lot of sites. But where we do have sites in general, as of early March, we had above normal snowpack values and generally below normal across the southwest portion or southwest mountains in New Mexico and the south central mountains in New Mexico. And looking at what occurred in March, wow, we really warmed up. We really got mild across much of the geographic area. It was much drier than normal across much of the area. And we can see the snowpack. We had a pretty active period up and through early to mid-January and even into February. But up until that point, we had good snowpack. But by late March, wow, we really got much drier. You can see these values here across portions of the far western Gila, the White Mountain area, generally less than 25% of normal. Far northern Mogollon Rim held pretty well, and still is right now, above average. Far northern New Mexico and into adjacent Colorado, still at this time actually still slightly above average, but even some of the areas around Santa Fe dried out a lot in March. So looking at kind of the weather pattern here, and this is one of the trickiest slides to portray and to talk about and discuss, because as you probably everyone certainly knows, the weather pattern is one of those that changes frequently. So although I can draw a schematic about how the pattern might be for the overall winter, we all know that weekly it changes, daily it changes, certainly monthly it changes. So this is not by any means perfect in the large scheme of things. But when you're looking at this is April, May, so the present month into May. Our jet stream kind of dipping from the northwest and kind of crossing the region right here. More recently, it's been more of a northwest to southeast trajectory with some systems kind of dipping across the northern half of New Mexico. And I think we'll continue to see that type of setup here as we go into early May and probably through much of May. In general, that we've up until this is symbolic of how things have changed. This was the map that we had a few months ago for April and May, where now the pattern is a bit different. We're expecting cooler than normal conditions in this area along with the wetter conditions here. And we're expecting drier conditions out west of the Continental Divide and warmer conditions out here as well. So it's kind of shifted around a little bit. But this was the pattern setup, which was more representative of perhaps the February-March time frame, where we had a lot of these incidents here in these portions of the eastern plains, where we had a bunch of these fires out in here. So some of these record-setting events, several 100,000 acres burned in one day, which is that's really what these big one-day wind events are like during the springtime. So while, I think when we say vast uncertainty, this is kind of started to decrease or shrink, if you will, as we get here into almost to May. I think we have a lot more understanding now at this point of how things are likely to evolve as we go through the next 6 weeks or 8 weeks, because really our fire season ends, it peaks seasonally here, or regionally here in the Southwest, it peaks in late June. So we'll see how this pans out, but we have about 8 weeks left. We typically peak in late June, and I'll show the forecast here in a moment. We did have a condition here, we still do, where there's El Nino. We have this past winter we were in a weak La Nina, then we moved into a neutral state in the tropical Pacific, and now there's the likelihood of moving more towards an El Nino as we get towards the fall. There's some indications that that's already trying to get going, but not enough evidence right now that that's a factor to impact our fire season. So some other brief factors here. These surges of moisture from the east that we've seen in the last few weeks, this has periodically been driven out by these wind events. We have these moist periods right here. We see a bunch of moisture climbing into the eastern half of the state, and then we get a big wind event drives that moisture out. So that's kind of been what we've seen, and I think we'll continue to see that as we go into May. We have a big system driving across the area. We had one yesterday. We'll see another one Friday, Saturday. It looks like we'll see another one Wednesday, Thursday, Friday of next week. So when you have these periodic, episodic, yet frequent or semi-frequent impulses driving across the region, it really impacts our fire season, and it will do so this year as well. And we just have on here areas near and east of the Continental Divide are expected to be the epicenter of these changeable and uncertain weather. So that's what we've seen. This area that I circled a moment ago that has that green there, I think that'll continue to be impacted by more of these more frequent events as we move through May. For an example, here's what I'm looking at. Might be difficult to see; it's a bit small, so I apologize for that. But this is Saturday morning. This coming Saturday morning, and this is next Thursday night, so about 8 days out. But this kind of storm at this time of year, and that's tough to see, but that's centered right over the New Mexico-Colorado border. I mean, we're looking at highs in the Albuquerque metropolitan area on Saturday, maybe low to mid-50s, which is 15, 20 degrees below normal. Even a one-day event that time of year, this time of year, can set us back a week in regards to impacting how the fuels respond and the moisture and the coolness. And we get another this is the Canadian model later next week. We get another one of these upper level lows, and this one drops kind of like southward like that from Montana, and it drops all the way across southeastern Arizona. And if we get that, we get a lot of moisture moving in from the east and that kind of setup. So if this does pan out, this is another example of an active pattern in early May, which will significantly impact much of the geographic area, trending downward, with the ERC values and all the dryness. Looking at the monsoon, this is factor number 5. This is kind of just giving an idea about the median dates for the end of our large fire season here across the Southwest. And as probably all of you are knowledgeable of, the season ends from east to west. Here in the east, we're seeing, pretty much things button up by mid-June to early July. Here in central New Mexico, western New Mexico, it's pretty much by almost all the same time frame, right around a few days after the 4th of July. Typically, we peak. Here in eastern half of Arizona, it's about mid-July. And once you get out here in western Arizona, it goes from, July 20th all the way to early August. So you can kind of see in 4 different sectors there how the moisture kind of moves. First it moves to the central mountain chain here in New Mexico, then it moves out to the divide, then it starts taking just pieces all the way out as you go into Arizona. So this is just kind of the median dates of the end of the large fire season here. Again, there's this potential for this rapid switch to El Nino, but that doesn't appear to be in the cards for this fire season. It was a bit dated, maybe about a month back. So in summary here, I don't want to read all this verbatim, but drought, not as much of a factor as it's been in the past. Few moderate areas that have emerged, mainly across southwestern Arizona and portions of the northeastern plains, but those eastern plains areas have moderated a lot recently. Fine fuels, generally normal to above normal loading and continuity area wide. I showed you some pictures of the eastern plains. Now they have been more moist and cool over there. That's really modified them a bunch in the last few weeks. Seasonal temperature precipitation. We had a real wet and mild winter, which kind of went in through January, and then February was kind of up and down, and March was much drier. So we really had into a kind of an up and down winter in the springtime. It's really been a dynamic and wild spring so far, and I think that's going to continue. We see a mixture of all these weather elements: some warmth, some wind, even snow across northern New Mexico this weekend. Northern New Mexico is not even on the charts at all right now in regards to fire danger. They're barely even inching up at all compared to normal. So they're well below normal for this time of year right now. They might never get in the game, and that's been our forecast, I think. Spring and early summer weather pattern. Again, this is kind of what we've been trying to get a grip on for the last month or two. It started out where we had a downslope type condition across the eastern plains, driving some of these fires across the eastern plains into Texas and Oklahoma. Now we're seeing more of a northwest flow pattern with some of these impulses dipping across New Mexico. I think that'll be the more predominant pattern into May. Well, you might even have some of these systems dipping across Arizona as well to help modify some of their conditions. So there's a little more certainty than there's been. This is perhaps a more of an overstatement here. Some uncertainty there always is, but we're more certain now than we were a month back. For the monsoon, this is always a question mark. A lot of it depends on what occurs in May, we've been able to find out through the years. So with this type of up and down pattern, there's probably some question marks with the monsoon, but right now we're still calling for an onset that might be a bit early, or at least on time, so perhaps late June, the first week or so of July. The bottom line, however, fine fuels aside, really no clear or highly certain alignment of badness, if you will, for no better term. It's been real difficult to get things to really align for this season so far. So with that being said, here's the outlook that we just comprised this about 2 days ago. This is May, June, and then July, August. As everyone knows, we're pretty much done by early July or mid-July, the way things work out typically. So for May, which starts just next Monday, really these areas in here are the areas of concern: southern Arizona, in the far southwestern New Mexico, and really those are the areas right now that we have the most considerations of issues. The only above normal areas in the region right now are officially western Arizona and southeastern Arizona. So everywhere else is average to below normal right now in regards to ERC values. As we get into June, we expect that area of dryness and warmth to kind of start expanding, so we started including more of pretty much like, I guess you could say, the southwestern half or so of Arizona as we get into June. New Mexico generally staying, milder, if you will, not quite as hot with regular heat, and a little more moist with some periods of moisture moving in. If you do notice here, we did keep this predicted services area in northern New Mexico in green, so we're expecting that to kind of coincide with some of the more moist mountains of Colorado and Wyoming and Idaho. So those areas we expect to continue to be kind of in a situation similar to Colorado with below normal fire potential as we go even into the peak of our fire season here. So again, I kind of just showed you the general trend. As we get into July and August, we're expected just to be back to near normal, which is pretty much where we're at during the monsoonal time frame. So really the focus is on these the mid and low elevations for the most part here, these brush and grass fuel types. It's possible we could see some more activity along the Mogollon Rim area as we get into the height of fire season and warm up during June. Really, without going further with everything, that's pretty much all I have as of right now. I'd be happy to entertain any questions, however, if anybody has any.
Well, that's great. Thank you, Rich. I think those outlooks are fascinating, so I really appreciate you coming on to do it. We have a small enough group today, so I'm going to go ahead and unmute the line, and people can ask questions just verbally. We also had a couple of questions. one came in from Don, and I'll read this one.
If you need technical assistance during your call, please press star followed by.
We maybe better keep it muted for a minute here. We got some background noise. So Don wrote in asking about your opinion. I think this is for you more, Rich. What about the influence of El Nino on the monsoon onset and strength? So if you could just talk for a second about how the El Nino pattern changes the timing of the onset and the strength of the monsoon.
Sure, I could probably talk for a long time on this, but there's it's quite complex, as you might imagine. And I guess one of the more additional complex items that's really evolved in the last few years here is that what we thought an El Nino pattern was, maybe in 2000 or 2007, is a lot different now in 2017. The reason I say that is because we're starting to see some evidence that there's different types of El Ninos in the Pacific Basin. We're starting to see some evidence that there's more frequent Central Pacific warmings compared to Eastern Pacific warmings. Now you're like, oh, big deal, it's just warming, right? Well, it is a big deal because it changes the weather, it changes the jet stream, the impact on these warmer areas in the Pacific Basin where the warmer conditions are located or peaking, that impacts the jet stream pattern. So we've found the last few years that we're starting to see more regular warmings in the Central Pacific compared to the Eastern Tropical Pacific, like the 82-83 event or the 97-98 event, which were the biggest events on record. The 57 event was another Eastern Pacific warming, but we're starting to see Central Pacific warmings like 09, like 2015. So these are starting to throw a monkey wrench into what we could normally in the past say, okay, El Nino means this for us. Well, not anymore. Now you have to start saying, okay, what type of El Nino is it? What other things are going on in the ocean atmospheric system? The weird synergy right now with PDO has been estranged the last few years. They don't seem to be rhyming. They're more conflicting than they are working together. So there's a lot of weird things that are going on now in the ocean atmospheric system that are a lot of times more regularly the last few years. They're kind of conflicting. They're not working together. So we're not seeing things work out the way they perhaps should. So that's an interesting thing. I guess in the past, typically with the monsoon, with the onset of an El Nino, we would see a tendency to having cooler and more moist conditions in the spring, which would really mess up our fire season here. So typically we peak in May and June. Well, in an El Nino spring, we would see much cooler conditions like we saw in 09, for example, in May and June, or more regular bouts of cooler conditions, or even near normal weather for temperatures, and more regular moisture, or in a time frame where we're typically dry. So that's typically what El Nino will do in the spring, mid to late spring. In regards to the monsoon time frame, what we've noticed in the past, it would kind of mess up the monsoon. It would lead it to be more sporadic. It would lead it to be more irregular, less focused. So in the past, that would be my take-home message for how an El Nino would impact the monsoon.
Great. Yeah, well, sounds fairly confusing, to be quite frank. There's a lot going on with these changes in the Pacific warming. Another set of questions, let's see, we'll go back to Pepe's initial question about prescribed fire, and he was pointing out that the Bureau of Land Management in Mexico has already burned 25,000 acres in this year. And how we kind of think about that, and I think also it's worth thinking about how the weather setup facilitates or inhibits prescribed burning this year. And Tim Kirkpatrick sort of added to this about recruiting more private landowners to do prescribed burning. And so I don't know what other thoughts folks have. You can go ahead and type them in, but it does seem as though years like we're setting up for in 2017, where conditions might be suitable for more prescribed fire, even during the wildfire season, the summer season, because of sort of cooler, moister conditions, it is something that we'll want to kind of add into some of our fire season overviews a little bit more, and maybe, as Tim is hinting at, sort of try to take advantage of these years, because obviously not all years are like this, and maybe this is a year we have to take advantage of. Let me see. I guess, I just noticed we're coming up into the top of the hour, so I certainly understand if folks have to drop off the call, but maybe we'll stick around just a minute or two more here and continue the conversation. And Tim is also noting that better success with fall burns. Let me see if we can unmute the line here. Yeah, it's fairly clear. So, Tim, I don't know if you want to just verbally sort of talk through some of your comments here. Oh, maybe it's still muted. Sorry, Tim. Okay. Let me address another comment that came in from Don about reburning areas and some of the things we saw in 2016, and we may see again this year as fires overlap. And Don was pointing out in his comment that some of the overlap seems to result in high-severity fire, and other kinds of overlap seem to result in low-severity fire the second time. And he's wondering if we have, or I particularly have, an understanding of how we end up in these contrasting outcomes. And I would say that the sort of fire season overview doesn't get enough detail to really answer that question. That's kind of another level of analysis we'd need to do. But it does, I think other research I've seen lately seems to suggest that there's probably a link between how the severity of the first burn. So I think the example from the Juniper fire with the Coon Creek fire, at least some of that area burned at high severity in the Coon Creek fire, and so reburned at a high severity in the Juniper fire, and that's certainly a pathway we've seen in things like the Las Conchas fire. Whereas in contrast, the McKenna fire and the Gila, you were layering more moderate to low severity fires on top of each other and sort of reinforcing that pattern. So that would be my guess, but as I say, that's a whole separate research project that hopefully someone should be working on. Other questions or comments? I think the line is open, so you can ask them verbally or you can type them in.
So this is Pepe. So one of the things he mentioned a lot the word normal, and I was just wondering what time period that normal is based on these days. Is it like the last 10 years or 20 years, or including the 1970s, or what? Oh,
good question. Rich, you want to take that?
Yeah, it's based from the last 15 years.
15 years. Okay.
Right, things kind of change, so we try to stay with that.
Okay. All right.
Good. Well, we're a little over time, so maybe we'll wrap it up here. I want to thank everybody for participating, and Rich, I particularly want to thank you for taking the time to give this overview. Really informative. And if those of you listening also feel like you want to share this with your colleagues, we'll have a recording online, so you can, both parts, you can share, and then of course the Predictive Services keeps their Outlook updated on their own webpage. So thanks again for participating, and I hope to see you at least virtually on future webinars.
All right. See you guys.
Thank you.
Thank you.
Thank you.